We are going to discuss about the different windowing techniques, and these windowing techniques are basically used for FIR filter design. As the name from FIR we know the full form of FIR is finite impulse response, and before that finite impulse response the name suggests is finite means a particular sequence is there. This is not infinite. So previously it was IIR. So from the IIR to FIR filter we are coming here, right? And there is also one middle term is the filter. So filter means something we have to take on a particular thing that we are not going to. Suppose we have a big room, and in our classroom we have 38 students in your BME department or any department. From these 38 students, those who scored 80% marks or 75% marks, those will be those 75% scored students will be called to a program to felicitate, right? So that means we are filtering out from the total number of 38 students. Among these 5 or 6 number of students, they secured 75% to 80% marks in the semester. So the windowing technique is the one important technique for designing FIR, means finite impulse response filter. So the other method is the sampling method, but we are not going to discuss here this sampling method. Basically, we are going to discuss here on these windowing techniques. It is used to make or convert the infinite sample to finite sample. That's what I told you earlier, that infinite sample means infinite impulse response IIR. From the IIR we are making it finite. So see, we have infinite samples here. Suppose this is a kind of sequence XOPN or any sequence has started some from minus infinity to plus infinity, or from minus pi to plus pi, right? From this infinite sample, suppose here we have taken, suppose one is hn, this is the input I have taken, suppose one is hn. So this is infinite sample. Here this sample is going up from minus infinity, is from the plus infinity, sorry, this minus pi to plus pi, or minus infinity to plus infinity. But what we are doing here, we are doing some kind of, just like a kind of window shape is there. So from, suppose, as I told you, are given the examples of the students in a classroom. Among all the students, we are choosing only the 5 or 6 students. Those number of students, they scored a secured 75% or higher marks in their examination, semester examination. So they will be passing through this window. That means from this number of, suppose n number of, here infinite number of sample sequences there. So from this infinite sample of sequences, this actually we are going to make it finite predefined samples, those what we want to passes through, and that is the window. Through window, this is the kind or shape of this kind of window. That is why the technique is known as window. So here we have taken this wn means windowing techniques. H of n is the infinite sample. This is my infinite sample, and h dash n equals to the finite sample of finite sequence. In a physical way, we can say that hn, this is my input. So here we are doing some kind of filtering, through these filtering or windowing techniques. So that gives you, this is my output, this is my output, and this is my input, and the input sequence is infinite sequence. This is my finite sequence. So mathematically we can write h dash of n, this is my h dash of n, this is my output, this finite sequence equals to h of n equals to this infinite impulse or infinite samples, and that is going to multiply with this wn. What is wn? Wn is the windowing techniques. That means we can say that when an infinite sample is multiplying by a window technique, a finite age of some fixed samples will provide the output as a finite sample. Now say, This is, we have taken one h of n infinite sequence, maybe from minus pi to plus pi, or minus infinity to plus infinity. So here we have taken the sequences 0, 1, 2, 3, 4, 5, 6. This is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Right, total 13 sequences we have taken here. And this is our W of n. W of n equals to, here we have taken 1. And this is for from minus 2 to 2. That's because suppose we are going to multiply. So whenever we are multiplying one sequence with the other sequences, the area of this particular sequence, that means this area is going to multiply with this. So that means only we are going to cover only here 2 to 4 sequence. So this 0, 1, 2 and minus 1, minus 2, total 5 sequences will be there. So here we have taken h of n equals to h of n into w of n equals to h dash of n. So that means this is a common area we have taken. Now, so finally we are getting this is a finite sample. From here we can say that window technique provide a fixed sample edges and the rest value is not there. That means that this is my rest value, rest samples. After this the samples are getting 0 as because w1 equals to 0. So whenever we are multiplying the rest means h of n, suppose these 3, 4, 5, 6, these samples going to multiply with this 0, so obviously we'll get the output as 0. But here whenever it is going to multiply with this 1 in this one, so the same sequences here I will get here, right? So having 0 the other samples, when we will multiply the fixed value with our input samples, it will exist or gives the same input samples for the fixed values. But for the 0 values, samples of the windowing techniques or the window samples will provide the 0 values as an output for the input samples, having samples, because we want the same particular value samples to pass through, some particular value samples to pass through, not all the input samples. Means basically we are doing or applying some kind of filters. So to design a FIR filter, it is very useful technique. Now suppose if I put a block diagram here, I have taken HN, this is my input, and this is windowing technique, this is h dash of n. So this is my infinite response, this is my finite. So we are excited with this infinite, we are getting this output as a finite. So here also the same thing already I previously discussed. This is my h of n, this is wn, and then finally we are getting this h dash of n, h of n. So this is negative half. Here one thing I need to say, when h dash n is equals to negative half, this is the only negative half as well as the positive half, both halves are taken along the vertical axis. It exists. That's not called as a causal window. It is called as anti-causal or non-causal window or non-causal filter. But now suppose if I take h and only the right side of right half, right side of this way, the right side multiplying, so other part will be 0. So only the right hand side, that means this is my causal window. Here we are getting RHS, means right hand side from the vertical axis, or only the positive half of the sample sequences. This is known as the causal window or causal filter. So if somewhere you are getting that a question has been asked to you to design a causal filter, obviously we have to take this right side, not the left side. Now what are the different techniques of windowing? So basically there are 6 number of windowing techniques, and these are: number 1 rectangular window, number 2 Hamming window, number 3 Hanning window, number 4 Blackman window, number 5 triangular window, it is also known as Bartlett window, and number 6 Kaiser window.